We all have bad days when after dealing with a cryptic stack trace error or an elusive memory bug, we think programming is really hard. But if you think mainstream programming is tough, let me introduce you to a whole new level of pain. Enter esoteric programming languages. For a bit of context, programming languages are more than 8 decades old. In the 1950s, the USSR was launching Sputnik, Elvis Presley was topping the charts, and in a quiet lab at IBM, a team of engineers were finalizing the design for what would become the first widely used high-level programming language. This was the start of a new era. Instead of manually flipping switches or feeding in punch cards filled with obscure machine instructions, programmers could now pass commands to machines in a language much closer to human speech. As decades passed, programming languages evolved to meet real-world needs. We got COBOL for business, C for low-level programming, Golang for building systems, Java for enterprise boredom, and JavaScript for non-technical programmers. Each one promised better tooling, better safety, and better abstractions. But somewhere along the way, during tight deadlines and financial constraints, the creativity and fun of programming kind of got pushed aside. This is where esoteric programming languages come into play. Unlike the boring mainstream languages, ESOLangs aren't designed to solve business problems or optimize hardware. They exist to challenge, to amuse, or sometimes just to troll. These are languages where readability is a joke, syntax is pain, and writing even the most basic program feels like solving a Rubik's Cube underwater, blindfolded, wearing oven mitts. But here's the twist. ESOLangs are more than just programming jokes. They expose the assumptions baked into modern language design by challenging the norms. They remind us that code can be expressive, absurd, and, at times, utterly beautiful. To really appreciate esoteric languages, we have to take another quick tour through history. The 70s and 80s were a time of rapid innovation in computing, but they were also deeply conservative in how languages were treated. Serious people wrote in serious languages. Your options were mostly limited to whatever was being used in academia, defense, or business. But by the 90s, the landscape started to shift. Personal computing was on the rise, the internet was starting to emerge, and programming was becoming something people did at home for fun. And so, naturally, someone wrote a programming language just to mess with people. That someone was Urban Müller, a Swiss physicist who, in 1993, created a language so minimalistic it made assembly look verbose. He called it Brainf. Brainf is built on just 8 commands, all single characters. That's it. There are no variables, no functions, and no OOP bullshit. It operates on an array of 30,000 cells stored in memory and a data pointer. You can move the pointer to the left or to the right and then increment or decrement the cell value. So, if you're trying to build a number, you'll be hammering the plus key quite a lot. You can then output the character represented by the ASCII value at the current cell, or use the comma to read one character of input and store its ASCII value into the current cell. But if you think this is too much manual labor, don't worry. Brainf has you covered with a loop construct. What's fascinating is that brainfuck wasn't just a joke. It was a deliberate experiment in language minimalism. Müller wanted to see how small a compiler could be. And, as it turns out, the compiler can get under 200 bytes. That's smaller than most modern JavaScript libraries that do literally nothing. Over time, brainfuck gained a cult following. Developers began to compete in writing the most absurdly complex programs with the fewest readable characters. Entire communities sprang up around it, pushing the limits of what was possible with almost no syntax at all. But if brainfuck was minimalism taken to the extreme, our next ESOLang took the exact opposite approach. Intercal holds the title of the first ESOLang ever created. It was released in 1972 by Don Woods and James Lyon, 2 Princeton students who wanted to parody the increasing complexity of existing languages. They looked at Fortran and COBOL, and they were inspired to make something as confusing and unpleasant as possible. The result was a language where normal conventions were thrown out the window. Variables are given numbers instead of names, types can be spot, two-spot, tail or hybrid, and the compiler can reject code that's either too polite or not polite enough. In other words, you have to balance your usage of the word please to an acceptable level. Too few, and it would refuse to compile, too many, and it would accuse you of being insincere. Intercal doesn't stop at quirky syntax or obnoxious compiler behavior. It also features commands like come from, a parody of the widely criticized goto statement. Instead of jumping to a line of code, come from waits until another part of the program executes, making control flow completely unpredictable. But maybe my favorite command is give up, which ends the program and, coincidentally, describes exactly how I feel every morning when I get out of bed. Funny enough, the Intercal documentation describes the language as a language worse than Fortran, which back in the 70s was the benchmark for pain. But perhaps no ESOLang better captures the spirit of sheer absurdity than the one written in whitespace. Created by Edwin Brady and Chris Morris in 2003, whitespace is a language where only spaces, tabs, and line breaks are considered code. Any other visible character is ignored entirely. This means that you could hide an entire program inside a regular-looking text file and, unless someone specifically checked for whitespace-only instructions, they'd never know it was there. So, it should not come as a surprise that a Hello World program in whitespace looks a bit different. Despite it sounding like a complete joke, in whitespace you can manipulate the stack, do math, access the heap, use flow control, and do input and output with the language being Turing complete. Today, there are hundreds of esoteric languages out there. Some are designed to be visual and let you write programs using abstract art. Others are written entirely in emojis or in Shakespearean English. Esoteric languages remind us that programming isn't just a tool for business. Sometimes it's about control and precision, other times it's about breaking things just to see how they work. So, when you're stuck in a sea of YAML files or trying to figure out why your Docker container won't build, remember that someone out there is writing an entire operating system in Brainf and they're doing it for fun. Before wrapping things up, I have something important to tell you. If you like deep dives into tech, economy or business, I just launched a second channel where I'm posting more in-depth looks at stories I find interesting. So if you want to see more content with my annoying voice in it, please check my new channel linked in the description. Until next time, thanks for watching.